Hey guys, today we will be doing a practice problem from AP Physics, Chapter 7, and this is talking about the interaction of objects, or the effect that forces have on multiple objects, not just one. So this is problem 31 from the physics textbook, and I think it's a very good practice problem for analyzing how forces are going to affect hanging objects. So the question reads, a figure shows two 1 kilogram blocks connected by a rope. The second rope hangs beneath the lower block. Both ropes have a mass of 250 grams. The entire assembly is accelerating upward at 3 meters per second squared by a force F. So immediately it's going to be, there actually is a figure to this problem, but what I'm going to do is I'm just going to sketch a quick representation because I didn't have room to draw it. But essentially there's this force F, right? So that's force F. There's going to be one block, so block 1, string 1, block 2, and then string 2. And what it says is these are not massless strings. They have mass, so we have to take that into account as well. And basically, our knowns are, so we know the mass of each of these things. So each of those are 1 kilogram, 1 kilogram, and then this is 0.25 kg and 0.25 kg. I'm sorry it's a little small, but I just didn't have room to fit the figure on there. So we know the mass, and another known we know is that it's always going to have a constant acceleration in the y of 3 meters per second squared. Okay, so the first thing I'm going to do is I'm going to draw a quick generalized free body diagram. And what I mean by a generalized free body diagram is I'm going to draw a particle, and I'm going to say this particle is going to represent any one of these objects. So in this case we would actually have 4 independent free body diagrams because there's 4 objects. There's going to be object 1, 2, 3, and 4, because remember both the strings are objects because they have a mass. But in this generalized free body diagram, I know that there's always going to be this upward tension force, and I know that there's always going to be a downward force of gravity. Now those are 2 generalized forces that I know are going to be on every one of these objects. So I'm going to work with those for now. And I encourage you guys to, at your house or however you're practicing this, draw all 4 free body diagrams. And it will make it a lot clearer in your mind if you draw all 4. But for now, for time's sake and just to show you guys a quick way to do the problem, I'm just going to use a generalized free body diagram. So that's my generalized, and in my generalized I'm going to start, so part 1 says it should actually say what is the magnitude of F. So we're trying to find out how many newtons F is. So we know that our F net in the Y is going to equal our tension minus Fg. And I'm getting that from this free body diagram. So do you see how it's tension minus force of gravity? And I know F net is going to be nothing but our mass times acceleration y. It's going to equal tension minus Fg. And in this case, since it's saying what is F in this case, so if we look at it from object 1's free body diagram, if you draw it, F would be your upward force. So tension is always going to be the upward force. So for the whole thing, I'm going to write it as tension is going to equal, and real quick, I want to point out, if you remember, force of gravity is mg, right? So our tension is going to equal, so it's going to be may plus, right? So may plus mg, m times g. So tension equals may plus g. Now that's easy enough, and I want you guys to remember this equation. So what I did here was I didn't start immediately plugging in numbers, right? I worked with my variables first, and it's going to make the problem a lot easier, especially because I see that there's 3 other steps which I'm going to have to solve for. So once I did that, it says what is the force of F? So at this topmost point, I know that I'm going to have to take into account the mass of all of these. So what I encourage you doing is whenever it says the force at a point, I would make that point on whatever your visual representation, circle everything underneath it, and that's what's going to be affecting your Fg. So that's what's going to be bringing into account your mass. So in this case, we're going to have tension. It's going to equal our mass, and in this case our mass is going to be 1 kilogram plus 0.25 plus 1 plus 0.25. So it's going to be 2.5 kg times, and we know that our acceleration into y is this constant 3 meters per second plus g, which is always 10. And this is going to give us our answer of, it should be 32.5 newtons. So that was easy enough. And now, since we have this generalized equation, I know I'm going to use it for all the other parts, right? Because it says that's going to say what is the tension at the top end of rope 1. So we've got rope 1 here. I'm going to draw my point on the top end, and I'm going to circle everything, including that point, and everything underneath. So if I make this circle around here, I know my mass, so let me just write that again. Tension is going to equal mass times acceleration y plus g. Right? Acceleration y is never going to change, so I don't have to worry about it. G is never going to change because it has a constant value. The only thing I'm going to be worrying about is my mass. So in this case, if I make that my point, circle everything underneath, it's going to be 0.25 kg plus 1 plus 0.25 kg. So it's going to be 1.5 kg, 3 meters per second, plus 10, right? And that's going to give me 19.5 newtons. So that's my answer for part B. Now part C, same thing, tension. So I'm going to go ahead and write it right here. M, A, Y plus G. So, I mean, now we realize why this working with my variables until the very last point makes it quicker, right? Or else I would have to do all this in my FNet all over again for each part. So this just makes it faster. So that's going to equal, now it says tension at the bottom end of rope 1. So if I draw it at the bottom end and circle that point and everything underneath, the difference is I don't have to take into account the mass of this rope. So once again, remember, since this rope has a mass, we can't assume that the tension on all the points of that rope are equal, because they aren't. So if I draw my point, circle everything underneath, that 0.25 is going away from my mass up there. So that's just going to be 1 plus 0.25. So it's going to be 1.25 times 3 plus 10. And that's going to give me 16.25 newtons. Perfect. The last part, it says what is the tension at the top end of rope 2. So again, I'm going to draw tension equals mass AY plus G, which is going to be, so top end of rope 2. So if I draw my point up here, circle that point, everything underneath, I know the only thing I'm taking into account is the mass of rope 2. So it's going to be 0.25 kilograms times 3 plus 10. That should give me my final answer of 3.25 newtons. So now, the very last thing that I think we should start doing whenever we're dealing with forces and interacting objects, just check to make sure our answers are reasonable. So basically, with all this work, we're saying that the tension at the top is greater than, tension decreases as it goes down. And if you think about it logically, it makes perfect sense, because as you go down, you're taking less masses into account. So your force of gravity is constantly decreasing. So your tension doesn't have to be as high. So I think it's reasonable, all our answers are reasonable. And so once again, this demonstrated how we should wait until the very last minute to plug in numbers, because maybe we can get this simplified expression. And finally, I encourage you guys to draw all 4 free body diagrams. And just a hint for all 4 free body diagrams, remember that rope 2 is going to have 2 forces pointing downwards. And that's just my hint, so if you guys want to try drawing all 4, go at it. And hopefully this helped you guys. And I know it's a very intimidating topic, because it's very hard to realize which forces are acting on what. But hopefully this helped, and good luck.